All right. Good morning, Ops Warriors. Good to see y'all. I hope y'all are having a great week. We'll get into it. On the screen is the map check. Here's where we are today, Tuesday, the 28th of April. And today we're going to go in the other half of control charts, statistical process control part 2. That's going to be P chart and C chart. On Thursday, we'll do a we drive, so some practical work, some examples of the P and C. And then coming up on Sunday, we've got the final blocks of Pearson. That's homework 3 Bravo and 3 Charlie. A couple problems on each P and C. This time next week, we'll have a slide I'll have a slide presentation on total quality management and lean. On total quality management, we'll go through the fishbone chart, which is a way that you can take action after noticing a process is out of control. So you see a process is out of control, and this is a way to kind of dissect and approach the problem. And then the discussion on lean is more about a counter approach, particularly to inventory, although lean is most associated with production. It's just kind of a neat way to wrap up the course. Then on the 7th of May, we'll do a class photo on Zoom. That'll be interesting and fun. And then more importantly, we'll go into our final prep for the exam. Anything that you want to cover again, talk about rules of engagement for the exam, all the normal stuff we do during a prep session. On Friday, the 8th, 2 things are going to happen. One thing is I'm going to post your final interaction and participation assessments, and I'm offering reading day repetitions. So what's a reading day rep? Well, number one, it's not mandatory, period. So reading day is for you to do what you need to do in preparation for finals, whatever that means to you. In the past, I've offered time, one-on-one slots for warriors who want to go over things with me one-on-one. So first come, first serve. Excuse me. So I'm doing it 9 to 12, 1 to 3 p.m. on that day. If you want to sign up for a 30-minute spot. Sorry. If you want to sign up for a 30-minute spot, go ahead and just email me now and say, hey, I want 1 to 1:30 or whatever. And if you don't, that's cool too. It's entirely up to you. And then on the 14th, we'll have our exam. I haven't looked lately on what the time we're slotted for that is. And I really honestly haven't thought about how we're going to do that. If anything, I'd give you just as much time as I gave you before. And maybe I'll give you more time than that. But we can talk some more about that in the future. Before we go on, do we have any questions on the map check itself, big or small? Okay, no questions, so we'll go on. Here's our agenda for today. We are recording right now. We'll review the purpose of control charts from a categorical perspective, what the purpose of P and C charts are, and then how to frame the difference between a P and C chart. And then I'm actually going to go flip this. I'm going to cover C charts first and then P charts. I was thinking about it this morning, and I think that might be an easier way to present this material. So that's our agenda for today. So first thing I'm going to do is fire up my little drawing pad here. Got some stuff left over from yesterday. Okay. So just a kind of in stride review. Remember, control charts, we want to control the performance of our process. That's the bottom line. Whatever it is we have going on in terms of our operation, we want to control that performance. And critical to controlling performance is identifying performance that's in control, that has normal variation, and then performance that's out of control, that's due to some kind of assignable variation that, that, you know, could be from a number of things. But for our purpose in our class, we've said 3 points consecutive out of control, either above or below the control limit, we would deem as OOC, out of control. And so the way that I like to frame control charts is up here we have X bar charts and we have R charts. And the reason we put these up here is because these are dealing with numerical variables that are usually things like speed, weight, it could be income, and these are continuous variables in terms of their being numeric. So when we say continuous, if I stepped on the scale, I might be 1.9117, blah, blah, blah. I mean, depending on how high speed the scale is, we could go 14 decimal places in this direction. So the point of me going back over this is when you see a problem and you're trying to decide what type of control chart should I choose, well, think about these things. Okay, what is the nature of my variable? Is it some kind of numerical continuous variable like one of these or something else? Time is kind of the big brother to speed, essentially the same thing. Does it look like this? If the answer is this, then yeah, I want to do these. And anytime I do a mean performance control chart, I want to do a range control chart too. Okay, so these really go, I'm just going to put a plus sign there. They really go hand in hand. You do one, you might as well do the other one. And that's our approach in this class. Now, conversely, let me use a different color, black, back in black. So when we're down here, these are, at least they begin as discrete. And more importantly, they are categorical variables. Okay. So don't get too hung up on the discrete part because pretty quickly we're going to convert them into decimals. And then you could argue that decimals are kind of like this. So I don't want to get you confused. I want you to focus on this word right here. When we say something is categorical, it's a yes or no kind of question. Okay. That's one way of looking at it. So, do you like pizza? Yes or no? Do you like Motley Crue? Yes or no? Do you like this class? Yes or no? That kind of thing. And in a different way of viewing that is, do you like waffles or pancakes? Well, I like waffles. You can only choose one. Do you like, tacos or, I don't know, pizza? I like tacos. You can only choose one kind of thing. So one common thing that really is used down here is errors. Okay. So when we're watching a shortstop or any player on the baseball team, how many errors did they make in the game? Well, they either made one or two or three, hopefully not, or four, probably not around anymore if they made four, that kind of thing. But at least initially, they don't make 1.2. All right. Or maybe they didn't make an error at all. Okay. So errors is a common thing that pops up down here. Another common example when we're talking about controlling performance is the number of complaints that we might get, especially if we're running kind of a service industry. Did you get a complaint today? Yes, I did. That kind of thing. So I might get one complaint, I might get two, I might get three, etc. Okay. So think about categorical variables. It's very much of a yes or no type of question. And so this is really the strategic decision that I want you to get in the habit of making so that when you see a problem and it's a control chart kind of problem, you can begin to frame it and say, okay, do I have this going on with my variable, or do I have this going on with my variable? And pretty quickly you'll develop the ability to frame. And then once you strategically frame, then you can get into tactical framing. So let's suppose that we are down here. We make that strategic decision that we're dealing with a categorical variable. Now we're going to have two types of situations. The first is a situation where we are not sampling. Okay, so this is kind of open-ended, and I'll explain and give some examples of what that means. All right. So we just have complaints coming in, we have errors coming in, but we're not sampling and we don't have an N. And in that situation, we're going to use what's called a C chart. Okay. The other so the first thing to figure out once we get into tactical framing over here is do we have an open-ended situation, or do we have a situation where we are sampling? And by definition, if we are sampling, then we have an N. Okay. So that's another way of looking at this. In my situation, do I have an N? Is there an N in the narrative? Do I have a sample size? If there's no sample size, then I'm up here and I'm going to do a C chart. If there is a sample size, or there's any notion of sampling, then I need to find out what that N is, because I'm going to need it to develop this chart. But I'm down here. Okay. And then we have formulas and processes for these. But generally, once we get down here, aside from the formula and the nuances of the formula, and we have a few nuances down here in P land, but the rest of the process is very similar to what we encounter up here. We're going to establish control limits. We're going to plot our data. We're going to put in the centerpiece of our chart, whether it's C or P. Up here, it's X or X double bar and R. We're going to put that in. We're going to put our upper and lower control limits. And then we're going to plot our data and say whether the process is in control or not. So we get to a point to, once we get past the formula, that there's a lot of in fact, the entire process is the same in terms of how we construct it and how we analyze and interpret it. So with that, but this is the main thing, and I have this chart on Canvas. Later today, I'll pull it up and post it again today. It's handwritten just like it is. It has the formulas on it as well, so you'll have that to refer to. But I would definitely get in the habit of this kind of methodology of framing these decisions. Am I looking at this, or am I looking at this? If I'm looking at this, am I looking at this, or am I looking at that? And then you understand why you're doing something. And then from that point on, it's a matter of procedure, which is relatively easy to remember compared to the framing part. Okay, so let's start with our C chart first. Okay. And like I said, our C chart is an instance where I'm not sampling. Okay. So let's suppose that I'm running a hotel and I work at the front desk every day. And throughout the day, people unsolicited, they check out, and I get complaints throughout the day. I'm not really looking for complaints, but they just come in. So Kylie stays at the hotel, and I check, I, I, she hands in her key and everything. And she says, the water was pretty cold. I could never get hot water in the room. And I said, okay. And I write that down. And then Tim checks out and he says, the food service was terrible. And so I write that down. And then Myra checks out and says, hey, there's no Starbucks here, so I can't get my drink with like 8 words in it. So that's 3 complaints for the day. And then the next day I kind of write down, how many complaints come in, and that's 5. And the next day I write down how many complaints that come in, and there's 4, and so on and so forth. So in this situation, I'm not surveying customers or clients at the hotel. I'm not asking every customer, hey, how was your stay? Do you have any complaints? Kind of thing. And if I did, that would kind of be along the lines of sampling. All right. Especially for it to be sampling, I'd have to ask the same number of customers every day if they had any complaints. But that is not this situation. So these are just kind of coming in. And in terms of uh, modeling theory and control chart theory and all these kind of things, these are analogous to arrivals into a system. And every time we model arrivals into the system, we use what's called the Poisson distribution. This is one of these Jackson Street things. Okay. And that's just the way we model that. And if you want a little bit more about the Poisson distribution, it kind of looks like this. But the big thing here is that our formula is going to be, so when we average these out, okay, you can guess that that's going to be C bar. So when we determine our control limits, we're going to determine C bar, and that's going to be these averages. It's not necessarily called a C chart for complaints, although I kind of think that had to have something to do with it along the way, because every example has to do with complaints. But we could come up with examples where they don't have to do with complaints. And then common to control chart patterns, we have a plus or minus here. We're going to begin with Z. So we still have to have a Z. That could be 2, that could be 3, that could be 3.5, that could be something else. And what's interesting about this is on the Poisson distribution, the standard deviation of this curve is actually the square root of the mean. So this is our formula for control chart for a C chart. It's actually quite simple. We just need to know Z. We only have to figure out one piece of data, and that's C bar, the average of these. And then we're going to put that C bar here and here. To determine the upper control limit, we'll do a plus. To determine the lower control limit, we'll do a minus. So what I'm going to do now is I'm going to just grab this formula here and take it with us to an example. Okay, and let me find my screenshot. All right, kind of big, but that's okay. So I'm just going to park this down here. All right, so let's suppose that, I don't know, I assign Pearson homework throughout the semester, and I assign it 10 times. And the first time I assign it, I get 5 emails of people complaining and asking questions. Hey, this is too hard. I don't really understand this. You didn't cover this part in class. And then with the second assignment, I get 6 people emailing in and saying that. Third time, 8, fourth time, 11, so on and so forth. And so eventually I decided at the end of the semester, I decide, okay, is this kind of normal complaints or not? Again, I didn't solicit any of these. I didn't survey the class and say, do you have any complaints? They just came in. Okay. So you could almost say this is almost a passive approach to control chart theory. I can give other examples that would would be that it's not necessarily passive. But anyway, let's say this is what's going on. So the first thing I want to do, and let's say that I just want to work with a Z of 2. I just arbitrarily say I want my control limits to be within a Z of 2. So the first thing I want to do is, just like I do before, I want to get a C bar, and I'm going to take the average of those, in this case, complaints. And that would be 13.5. And then, again, it doesn't have to fall in a certain order, but I don't know why I got that there erroneously. Let me get rid of that. I'm eventually going to do an upper and a lower, and I always like to just put those around those so I can remember that this is going to be greater, that's going to be less than. And I'm going to use my formula right here to determine that. So I'm going to grab that C bar, which is the cell below. I'm going to add it because I'm doing the upper one. I'm going to reference my Z, which is 2. And I'm going to do it square root times the square root of B15. So 20.84. And then down here, I'm going to do the other part of that, where I'm going to refer to that C bar. I'm going to minus. I'm going to refer to my Z. And then the square root of B15. Okay, so just looking at it, those upper and lower control limits look right. Looks like a big difference. Of course, I am dealing with, I don't know, looks right. I mean, I entered all my formulas correct. So the next thing to do would be to plot my data. Go into what I call the connected scatter plot right there. I only have to grab that one column. Looks like this. Might as well give it a title. And same as I always do. I'm going to get some limits down here. My upper's at 20.8, so roughly about there. And 6.15 is my lower. And my middle is, my C is 13.5. About right there. And then, I could approach the upper first, and it looks like I have some stuff going on that's out of control. But I always like to verify where I slap that line versus the actual data. So I like going through, just going to throw that down there real quick. And 20.84. So, yep, I have those 3 points there. I don't have any others, but they're above that 20.84. And I am okay if you just do, this kind of thing. I'm good with that. And then going back through and saying the lower side, and that would be anything less than 6.15. And I just really have this right here. That's a little bit low. Okay. And then and this point right here looks fishy. What is that? That's that point right there. So that's out of control too for that day. Almost missed that. And what about this second day? Same logic. it's 6 as well. So this right here is what a control chart should look like. I probably, if I want to put icing on the cake, I want to make these limits a little more discernible instead of these thin little lines. Color coding these over here, that's not even part of the chart, although it helps me identify when the process, I mean, it's a good double check. As you see, if I just eyeball it, sometimes I might set myself up for failure. So it's a good habit to go through the data, 2 passes, once for the upper and then again once for the lower, just to double tap and make sure. Now, let's talk about just analysis and interpretation. Well, down here, maybe the Pearson was, a little too easy kind of thing. But then the other side of it is maybe it was something's going wrong here. Maybe it's too hard. Maybe, I, I don't know, some kind of error. Maybe I assigned the wrong section and I didn't even realize it. Maybe there's some kind of ghost in the machine with Pearson. All those kind of things that are kind of assignable variation. And then these points that aren't circled, again, so those 2 right there, days 3 and 4, and then days 6 and 7, that's normal variation kind of thing by this. So that's a C chart. The big thing, very straightforward in my opinion, one of the simpler formulas we're going to see. If Z was 3, that'd be the only thing that would change. In fact, not to confuse folks, but the beauty of the model is we could put 3 in here and our upper and lower should change. Our C bar isn't going to change because Z's not inside of that formula. The problem, at least with the way we do these charts on Excel, is our control limits are not going to change on our chart. So we got to go back and adjust those. But that's really all there is to it with the C chart, with the exception of the interpretation. Okay. Any questions on the C chart? When to use it, how to do it, how to interpret it, those kind of things. Okay. I might as well talk about it now. Sometimes when we do, particularly in PNC, we will get a lower control limit that is negative, at least initially. So we'll get a value down here that'll be a negative number. When that happens, you just need to default to 0. So there's no such thing as a negative control limit. It just is not a thing. So like, let's say we get a negative 0.256. You're just you might, put that here, but to the side of it, I'd put a 0. And on your chart, I would just put that control limit on the x-axis, assuming that your XY axis, assuming that you haven't truncated it. So like we did before when we adjusted this Y axis. So if we've adjusted that Y axis, we've got to adjust it back because our control limit starts at 0. Okay. But I would just, in this case, if my control limit was 0, I would just take that lower control limit and I would set it right on top of that Y axis. Okay. But I don't have that going on here. I have it up at about 6. Okay, so that's the bottom line. No such thing as a negative lower control limit. Okay, so let's talk about the P chart. Okay, so that was our C chart. Again, so when we talk about P chart, it's not necessarily the opposite, but it is an instance in which we're sampling. Okay, so the P chart, the book calls it, the P is actually short for percentage. If I was king for a day, I would change that word to proportion. And I guess on the theoretical side, I honestly don't know what the difference is between these two words. The more that I think about it, um, why why do we even kind of care about these words? Is well, because when we think about what a percentage is or a proportion is, at the greatest it is 100 or 1. Okay. But usually it is less than 100 or 1. So it might be 0.99 or 99, or it might be 0.04 or 4. Okay. But it's not more than this. So it's not going to be 102, and it's not going to be, 200 kind of thing. Um, you might have percentages that are that in other disciplines, but you won't here because um, so in this case, let's take our previous example where we run the hotel, and you could have a situation that was kind of a C chart situation that you turned into a P chart situation. I could see that happening, or you could just have one that's independent of the other. So let's just say it's a different situation, but I want to make it so you can see the differences. So let's say that in this hotel, we ask every third person, we ask, how was your stay? Okay. We don't ask every person, but every third person, when they check out, we ask, how was your stay? And out of that question, we record the amount of complaints that we get for the day. Okay. And let's say that just mathematically, because we've had this class and we have these mad skills, we limit our questioning to 30 people a day. So right off the bat, we have an N of 30. All right. And we generate that 30 by asking every third person. Let's say we do the math. And so the reason we do every third person is we want some randomness because that goes hand in hand with sampling. But really the bottom line is we have an N of 30. We're not asking every single person that comes to the desk, but we're also not just kind of waiting for the complaints to come in kind of thing. This could be related to our earlier situation where we're like, okay, 5 complaints in a day seems like a lot, but we haven't really asked, more than that. That could be 5, that could be the only complaints there are. Okay. So let's say we have an N of 30, and out of that N of 30, we get 5 complaints on the first day. And out of that N of 30, different sample, we get 6 complaints the next day. So this is day 1, this is day 2, this is day 3. Let's say the third day, we get 4 complaints. And the fourth day, we get 5 complaints. Okay. So this kind of looks like what we did before, but here's the key difference. Because we have an N of 30, we are going to take the proportion or the percentage. All right. So instead of just taking an average out here, we're not going to do that. We've got to divide by that 30. So our data point for that first day is actually going to be 5 divided by 30. And our data point for that second day is going to be 6 divided by 30. And then our data point for that third day is going to be 4 divided by 30. And the fourth day, 5 divided by 30. Now, I think I put some slides on Canvas that show the formula for, oh, and by the way, we're going to take the average of these decimals. I just put them up here as fractions so that you can see how we got that conversion. All right. But eventually, whether we do it now or later, we're going to get the average of these numbers here. And that right there is going to be P bar. Now, back to what I was going to say. If you look on Canvas, I posted some slides for the formula for P bar. And having taught this a number of times now, I actually think the way that formula is more confusing and complicated than it needs to be. So I'm not going to walk through that formula. I'm going to do this method again in Excel. And if you want to look at that other formula, if you want to use that other formula, I mean, I always say whatever works for you. The other formula is correct. This method is correct. I feel like my job in the morning and at the end of the day is to make things simpler for you to understand and use. So that's why I go with this. But this right here is a very critical step. Okay. If you erroneously just take the average of these black numbers, you won't get number one, you won't get a P that makes sense. Okay. A P bar. Number two, you really, it, it, it just, once you start graphing things, it really won't make sense. What haven't I shown yet? I haven't shown the formula for the control limits. So let me clear up a little bit of space here. Okay. So this, before I do show that formula, let's go back to some comments I made earlier. So again, this is an instance when we start out, these are days, when we start out with a discrete number, 5, 6, 4, 5, but we're going to convert that into that proportion, 5 out of 30, 6 out of 30, 4 out of 30. And that's going to give us a decimal. So I don't want you to get hung up on, well, the decimal could be a continuous number. You're right. It could. It's still not going to be because it started with a discrete number. Formula time. So the control limits here, we have that pattern again where we're going to begin the control limit with P bar. And I'm just going to write the full formula. We're going to start this end with Z. So we still need a Z. And if you remember from QBA, and again, might be a little while back, and I talked about confidence intervals. So this is the same as a confidence interval formula. This is not a confidence interval, and it's still a little bit different, but the formula is just about the same, which is where we're going to take the square root of P bar times 1 minus P bar over N. Okay, so that's going to be our formula. Obviously, we need a Z. We've got P bar, so we can put it here, here, and here, and then we've got that N, and that N, in this case, is going to be 30. And please notice that nowhere in here is the number of samples. Okay, so the number of samples in our instance would be 4. We took a sample on day 1, we took a sample on day 2, we took a sample on day 3, we took a sample on day 4. But that is not N. Okay. So tattoo worthy. And warriors have a tendency to want to do this. So that's why I highlight this. The number of samples is not the same thing, as sample size N. Okay. They are not the same thing. All right. In this case, we took 4 samples, but the size of each sample was 30. Okay. I asked 30 people here. The next day, I asked 30 people here. Some of these might be inside of this 30. That's into technical stuff that at this point I don't really care about. But I asked 30 people every day. I did it for 4 days, 2 different things. Okay. This usually you've got to get out of the narrative. This will probably be right there in the table. So again, get very comfortable by making this distinction. And the other thing is just know from the formula what N is. N is a number of measurements. In this case, it was 30 measurements. Okay, so let's go to an Excel example. All right, so same thing. This time back to Pearson, although it doesn't have to be Pearson. Let's use something else. Let's say that I own a restaurant and I'm interested about no, that wouldn't let's go back to Pearson. Let's do Pearson. So in this example, I assign Pearson 10 times, but each time I assign it, I give students a survey. And of course, the assumption is that all 30 students fill out the survey. And let's just say that they do, okay? So the survey results from, I'm going to just change this to 30. All right. So I have an N of 30 right off the bat. And let's say I want to set control limits at 3. I don't know why I'm getting this down here. I'm going to get rid of that. Okay, so here's what my results look like. From the first set of Pearson, my survey comes back and 10 students say they had difficulties with that set of Pearson. And with the second homework, my survey results come back that 12 students out of 30 said that they had problems with Pearson, and so on and so forth. Okay, so you might want to, a tendency might be, oh, I'll just take the average of these. Well, you can't do that just yet. Okay. If you get some situation like this is a P-chart situation because I have sampling going on. I know that because number one, I'm surveying people. That sounds like sampling. And number two, I have an N involved. So that more than sounds like sampling, it is sampling because I have an N involved. So what I have to do is make a new column. And for that, I need to take this 10 right here and divide it by N to get that proportion or percent. Okay. And because I have mad skills, I'm not going to type in 30 a million times. I'm just going to grab that there and I'm going to lock that down. I could go bigger. Why not? Boom. Okay. And so now that I'm happy with what that looks like, I can just drag the sucker on down. Ooh, 100%. Now that's interesting. See, I kind of screwed up my problem. That's why I have that 1.03 there. Originally I had an N of 90, but it didn't make sense with the example I was using. So I screwed up my problem. Let's just say I have 35 students in a class, big class. All right. Those numbers make sense right there. Okay. Because in this instance, you really can't have something over 100%. I know there are instances in life where you can, but in this, with a P chart, you really can't. Okay. So those are my respective proportions. And I'm just going to give myself some space. Okay. And like everything else, I've got to take the average of those numbers. And that's going to give me P bar. Huh. That's kind of weird. Just a nice clean 0.5. Let's see if I can do this without a whole lot of hassle. My formula disappeared. I'm just going to write it again. So remember my control limit formula for P is P bar plus or minus Z times the square root of P bar times 1 minus P bar over N. So I'm going to take this with me. Come on over here. Okay, there we go. There's an old song called Martian Boogie by Brownsville Station that somehow comes to mind with this weird green. Anyway, sorry. So, like a good neighbor, like always, I'm going to establish upper and lower. That's kind of a habit we've gotten into. Okay, so let's see. Do I have everything to do that? Yep. With this kind of complicated formula, I mean, to each his own, pick your poison. You may want to break this out into different cells or not. I encourage folks to do that just because, I don't know, you could make a PEMDAS error. I could see that. But we're just going to throw it all in one big bunch. So we're going to refer to P bar here. Boom. In this case, we're going to do plus our Z times the square root. We're going to need double parentheses. I know that. Let's see what we're looking at. C14 times 1 minus C14. That's going to be ugly if I continue with that. And then we're going to need that divide and then wherever my N is. And just this past weekend, working with another warrior from another class, she did not put that. I probably have too many parentheses there. Let's see if Excel likes that. Yeah. She did not put that parentheses after that second C14. And she couldn't understand why Pearson, kept giving her a certain answer. Well, Excel's going to do what you tell it to do. So if you don't put that second parentheses in there, it's essentially a PEMDAS. I hate the word error, but that's what that is. Okay. And then we're going to do the same thing down here. Just, do that minus. So grab that. Up. Z times the square root of this whole thing. And wherever my N is, wherever I may roam. Okay, same. I do want to plot these numbers. Okay, not these numbers. I want to plot these numbers, and that's, at this point, it's easier. It's harder to make that mistake. You kind of almost have to try to make that mistake, but it is possible. If you plot these numbers over here in the B column and try to put these control limits, it won't be, it'll definitely be apples and oranges because these control limits won't even be on the chart. Okay. So we want to definitely plot these respective proportions. And I'm going to do that the same way I've always done it. Boom. Okay, problems with that girl who's always laughing at me. I don't know about you guys, but she's always laughing at me when I go to pull up Pearson, laughing at me about something I did. Never know what it is. Throw that lower control limit in there. That looks about right. Actually, should be a little bit higher. Good enough for now. Another one up here about there. And wherever that P is, 0.5, nice and clean right there. Again, I would ramp these up. Same, grab some circles. Whoa, it's like a lifesaver. All right, let's do the lower half first because it doesn't look like I have anything lower than 0.25, and I don't, but it does look like I have some stuff above 0.75, and I have this, this, and this. Okay. I don't know why that's there. Don't need that. Probably because I kind of got impatient. All right. So could could I keep working on this control limit chart a little bit? Sure. Yeah. I want to bring these out to be a little more prominent. So it's just like a cartoon in the newspaper or on the internet or a meme or whatever. When you see it, you instantly get it. And that I think transfers to the real world. When you show somebody a chart, you don't want them to be sitting there rubbing their head going, huh? You want them to get it. Ah, I see the process is out of control for those last 3 days. And you're like, you're right. And here's why I think it is blah, 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 blah. You don't want to create more work for them to do. You actually want to do the opposite. That is, if you want to be a player, be an ops warrior, and all those great kind of things, which I know you all do. So right there, we can see that the process is out of control for those last 3 days. Something is kind of slipped gears. Maybe again, the way that I've loaded Pearson, all those kind of things. This variation down here is normal variation. Okay. This up here is assignable variation, man, machine, environment, all those kind of things that we're going to talk about next week when we talk about the fishbone diagram. The key difference between this and the C chart, we have an N, we have a sampling situation where I'm surveying people. That really the big piece of this is me creating this proportion column. All right, which you're probably not going to get data that the proportion has been done. You're going to have to do that step. From that point, the rest of the process is the same. We have a formula to use. We establish an upper, a lower limit. We plot our data. We identify the points out of control, and we do the interpretation. I suppose the only other common error that you want to avoid is plotting the right data, the proportions, apples to apples, as opposed to apples to oranges. If you plotted this data right here, it wouldn't make the chart because the chart only goes to 1 and your data would be all the way up here. I rarely see that happen. Once folks get in the habit and they get it, they identify the type of chart, the P chart, they instantly are in the frame of thinking of proportions or percents, and these values need to be less than 1. Any questions on anything? P chart, C chart, X chart, R chart, any of this? Okay, so if we look at Canvas, this is not our Canvas, but this is Ono. We look at our Canvas. And we go to Thursday. It's like pizza. Every picture of Batman is cool. But when we click on this We Drive right here, So looking ahead to Thursday, and these are not, quote, mandatory for you to do before Thursday, but this is what we're going to do on Thursday. So we have two problems here in this Excel data set. You got a little bit of a narrative, you got some data, you've got some questions. Okay, it's the Dark Knight Controls Part 2 and Part 3. So it's up to you. This is what we're going to do on Thursday. We'll do these together. I'll ask, you throughout, hey, how would you set this up? How would you approach this? What would you do now? It's not required. I feel like I've given you a lot of homework lately. So this isn't, quote, homework to do between now and then. If you don't do it between now and then, between now and Thursday, that's fine. Just know that going into Thursday, we're going to crack these open and do these together. So it depends on you, on how much you want to look at this between now and then or not. But that's what we'll do on Thursday. And with that, that concludes our fun for today. I will hang out until you all have cleared the call. And otherwise, if I don't talk to you before Thursday, have a great week.
Have a good one.
Thank you. You too.